Okay, can you guys see my slides?
Yes.
Okay, all right. Well, hi everyone. This is a joint work with Orhan Aygün. Orhan is in the audience, so if you have questions, you can ask him over the chat. So, just a second. Thanks, David, for the nice introduction on reserve systems. So, as David mentioned, reserve systems has gotten a lot of attention recently, both theoretically and in practice. You see in my first slide very prominent examples where reserve systems have been used, adopted, or theoretically studied. So, David already mentioned, but just briefly go over this slide. So this is actually what I will be talking about is a sequential reserve system, which is identified by three components: reserve categories, processing sequence, and priority rankings. And what it is given a set of alternatives A, category first picks first, Q1 fills Q1 positions following its own priority ordering, and then among the remaining alternatives, category 2 tries to fill Q2 positions following its own priority ordering, etc. So if you look at real-world applications, you will realize that almost all reserve categories are exclusive, in the sense that only applicants with certain types of or characteristics are considered for a given reserve category. We have seen this in vaccine allocation during COVID-19, for example. Frontline health workers can be considered as a category, which is different than people live in care homes, etc. In Brazilian college admission, Orhan talks about a low-income minority student from public high school is considered as a reserve category, etc. So most often, reserve systems are paired with a de-reservation policy, and there's a good reason for this, because it is very common in many real-world applications that the number of positions are reserved, set aside for a given category is actually higher than the number of beneficiaries in that category. So what we will show in this paper is that the design and implementation of de-reservation policies are actually consequential. It matters. Well, reserve systems has been studied recently a lot, but that's not true for de-reservation policy. So I will be talking about, even though our results will be general and can be applied to almost any sequential reserve systems, we will consider affirmative action in India, especially admissions to technical universities in India, as our main motivation. So India is one of the countries using large-scale affirmative action to protect three types of applicants called scheduled castes, scheduled tribes, and other backward classes. And people who do not belong to these categories are called as general category applicants. So this is in Indian law that 15% of seats in every higher educational institution and government-sponsored jobs are reserved for scheduled caste, 7.5% for ST, and 27% for OBC. And the remaining 50% is 50.5% called open category positions. And you see here in this table who is eligible for what type of position. Open category, as the name suggests, open to everybody. SC, ST, and OBC categories are exclusive reserve categories, and those three are actually mutually exclusive. So admissions to technical universities in India recently actually changed. The allocation system recently changed by five or six, I think, engineers, and the whole process is summarized in Baswana et al. and there is actually a matching theorist in one of in this group. And since 2015, they have been using a new joint seat allocation process for technical universities. So this can be modeled as a many-to-one, one-sided matching problem. But what it will be crucial is this ingredient. So the initial distribution of positions at every institution or program will be dictated by law, and we will see this will actually play a very important role on how they handle the reservation, and it will be also important for our design. So each student has is going to have, or each applicant is going to have a merit score, possibly different at different institutions. And this function T here is going to denote reserve category membership. Okay. So these bullet points can be considered as institutional restrictions, okay, and these are all mandated by Indian law. So for SC/ST and OBC members, for them to receive SC/ST, OBC seats respectively, they have to declare their membership, and membership declaration is not mandatory, and this is crucial because when those people do not submit their membership, they can be considered only for open category positions. Basically, they will be evaluated as a general category applicant. Okay, so for each reserve category in every institution, merit scores must be respected to allocate positions. So this actually gives us how priorities are determined. And another important point is open category positions are allocated first, and then SC/ST and OBC positions. This is to give SC/ST, OBC members, an extra help. So by law, unfilled SC and ST positions cannot be de-reserved or cannot be, provided to the use of others. But with the 2006 Supreme Court decision, the situation has changed for OBC category. OBC reservation is very controversial because it is very large, 27%. And in 2006, Supreme Court decided that the unfilled OBC positions must be made open category positions and to be provided to the use of others. Okay, but they did not specify how, and that will be this paper is all about that. Actually, matters a lot, and we will talk about this soon. So. This is a baseline selection procedure that's actually widely used in many real-world applications. This is what we call this choice rule with reserves, which has basically 2 stages. In the first stage, open category positions are filled following the merit score ranking over all individuals. Okay, and then in second stage, among the remaining applicants, each exclusive category selects applicant with respect to their own priority ranking. Okay, so this is something very simple. Well, given the audience, I will skip this slide. Everybody here knows what a matching is and what stability is. So here. For the problem, we consider each applicant actually submit 2 pieces of information. The first one is their ranking over programs or institutions, and 2, their reserve category membership. Okay, and both matters, both will impact the outcome. So this is why we define a mechanism, allocation mechanism, from the Cartesian product of preferences and possible types into matching. So what we want is we want our allocation mechanism to be strategy proof, so that reporting through preferences is a weakly dominant strategy. Equally importantly, we want allocation mechanism to give reserve category applicants to right incentive to actually truthfully report their membership. Because if this second one is not actually satisfied by an allocation mechanism, actually the whole affirmative action plan cannot be really implemented well enough. Because we must let these people to submit their category membership truthfully, and this must be something that they help them, okay, not hurt them. So what is currently implemented right now to handle OBC de-reservation? Remember, SC and ST vacancies cannot be de-reserved, but OBC vacancies must be made open positions. Okay, so this is how Baswana et al. Do this. So they first run deferred acceptance on all candidates. Okay, and each basic institution use a choice rule with reserves. Okay, and they find a matching, and then after finding a matching, they look at each institution how many OBC positions are filled and how many OBC positions remain vacant. Okay, so what they do is they, if there's a vacancy in an OBC category, they actually update the primitive of the problem. They update the distribution of positions over categories. Okay, and with this updated vector, they rerun the deferred acceptance, and they repeat this until no OBC seat is left unfilled. So this, it is important to realize that you might need more than one iteration because of the following reasons. Suppose there were at a particular institution 5 OBC seats are left. Okay, so those 5 OBC seats are added to the open category positions, but some of those transferred open category positions can actually be taken by OBC students because open category positions are filled first. Okay, so then we will have newly vacated positions at the OBC category, so that we will need one more iteration to transfer those new vacancies to the open category. Okay. So here's an example, very simple. So there is only one institution here. So 5 positions are open, one for scheduled for one, reserved for SC, one for ST, 3 for OBC. So if you run this, first 5 students will get open category positions. Okay, student 6 will get OBC position, 7 will get SC position, and 8 will get ST position. All right, well, 2 OBC positions will be vacant, and those 2 OBC positions will be made open. So this number 5 here will be updated to 7, and 3 is going to be made 1. Okay, so now 7 students will be or individuals will be chosen for open category. The highest scoring 7, as you see, the only OBC student is now actually selected from the OBC category, so that we will have a new vacancy in the OBC category. And then in the at the end of the second round, we have to actually update this vector once again. So, okay, is it fine right now?
Yes.
Can you see my slides? Okay. Well, sorry for that. In the last stage, 8 positions will be open category positions, and students from I1 to I8 will receive open category positions, and that's it. The remaining 2 students will be unassigned here. So, so this is with a single institution, how multi-run deferred acceptance algorithm introduced by Baswana et al. Is run. What we show with very simple examples that actually this multi-run deferred acceptance mechanism is manipulable by both preference misreporting and not reporting reserve category membership. We showed this a very simple example with two institutions and 4 students, but let me move on. I'm not sure if I will be able to finish. Okay, so basically the main idea here, and this is through truncation, the main idea is by truncating, actually students might have ability to alter the update of positions over categories so that the resulting outcome can be changed. Okay, so similarly, multi-run deferred acceptance is not incentive compatible for type reporting. In the example, student I4, which is a member of OBC, when she does not report her membership, she can actually get a better assignment. Okay, so we we design a new schemes for de-reservation via choice functions. So the issue actually with the multi-run deferred acceptance is actually caused by rerunning the DA to adjust capacities that gives individuals a new channel to actually impact the adjustment by preference and reserve category membership misreporting. So what we do, so actually what we do is very straightforward. We thought why they do this, why they try to handle the reservation by rerunning the deferred acceptance, but why not just run deferred acceptance only once, but rerun the choice rule with reserves with updated distribution of positions within the steps of deferred acceptance. Okay, and then the next question is how they reserve vacant OBC positions. They can similar to the multi-run deferred acceptance, actually the backward choice rule ideas coming from what is currently implemented. Within the choice function, OBC seats can be transferred to the open category, which is filled first, or we can create a new open category positions at the very end. Okay, so the difference, I will be talking about the difference between them. They are both cool, but they have very different actually properties, and depending on what policymaker wants to achieve, we can actually suggest one or the other. Okay, and then as a centralized procedure, we propose deferred acceptance with respect to these choice rules. So again, this is backward transfer choice rule. So this is how it operates. It operates in multiple iterations. So in each iteration, we run a choice rule with reserves, but each iteration, we actually, if there's vacancy in OBC, we will transfer those positions to the open category, and we will update the vector of positions over categories. Okay, and we will do this until there is no OBC vacancy. Okay, so first we show that the backward transfer choice rules actually incentive compatible for reserve category membership. So what this does is that if there is only one institution, okay, and that institution uses backward transfer choice rules, okay, then okay, type revelation will be truthful. Okay. Our second result shows that deferred acceptance mechanism with respect to backward transfer choice rules is strategy proof, and we show this by showing that backward transfer choice rules satisfies substitutability and size monotonicity. Okay. And the deferred acceptance with respect to backward transfer choice rules is also incentive compatible for type revelation. So it has all the nice incentive properties. So what was unexpected is the Pareto comparison between multi-run deferred acceptance and deferred acceptance with respect to backward transfer choice rules. So this theorem actually was very difficult to prove, and I can say it is the strongest result in this paper. So the deferred acceptance mechanism with respect to backward transfer choice rules, weakly Pareto dominates the multi-run deferred acceptance mechanism at every problem P cross T. So what I was telling, our strongest result is actually this theorem that shows deferred acceptance with respect to backward transfer choice rules. Pareto dominates multi-run deferred acceptance at every problem P cross T. And the way we show this is that we show that when we fix P and T, the type profile and the preference profile, the outcome of multi-run deferred acceptance is going to be stable according to the stability notion defined with respect to backward transfer choice rules. Okay, so because of that, we have the following corollary actually at the multi-run deferred acceptance and deferred acceptance with respect to backward transfer choice rules, the same number of individuals are going to be matched. But we might have Pareto improvement. So the forward transfer choice rules is just, creates an extra open seats at the very end and transfer vacancies from OBC to the end. Okay, so similarly, it have all these nice incentive properties. Basically, deferred acceptance will be incentive compatible and strategy proof. And in the last part of the paper, we actually compare backward and forward transfer choice rules. Well, here I think I don't have time, but let me tell you what this is. So backward transfer choice rules transfers vacancies from a category to another one that preceded, and forward transfer choice rules transfers categories to the end. So basically, if policymakers wants to maximize merit, the forward transfer choice rules is the better option. If they want to give extra help to SC and ST students, it is better to use backward transfer choice rules. So basically, we define a merit-based domination criterion between first two sets and then between two choice rules. And we show that forward transfer choice rules actually merit-based dominates the backward transfer choice rules. But this is only this holds only when we compare choice rules. When we compare deferred acceptance mechanism with respect to backward and forward transfer choice rules, this does not hold anymore. Okay, and also deferred acceptance with respect to forward and backward transfer choice rules are Pareto incomparable. Okay, so here let me conclude, and I'm again sorry for the technical difficulties. So we show in this paper how the reservation policies are implemented matters a lot. We introduced two families of choice rules and the deferred acceptance mechanism with respect to them. And we showed that actually one of them, the deferred acceptance with respect to backward transfer choice rules, Pareto dominates the currently implemented mechanism. And here's policy suggestion. If there is a single institution, we recommend the use of forward transfer choice rules if meritocracy is the concern, and we suggest the use of backward transfer choice rules if additional protection for SC and ST is the concern. Okay, in a centralized marketplace with multiple institutions, deferred acceptance with respect to both forward and backward choice rules are strategy proof and incentive compatible, so they both have nice strategic properties.
Okay, thank you, Bertan.